Hello everyone, welcome you all back to my channel. Today we are diving into an essential topic for GCSE and IGCSE computer science, that is data representation. So in this data representation chapter, we are going to discuss about different binary conversions like decimal to binary, binary to decimal, binary to hexadecimal. So why do we need to know these binary conversions? Reason is computers don't understand human language. They only works with ones and zeros, known as binary. Therefore, all sort of data needs to be converted to binary, such as alphanumeric data needs to convert into binary, image data needs to convert, audio data needs to be converted. So all this data needs to be converted into binary. So first of all, we'll see how to convert decimal numbers into binary. There are actually two methods to convert decimal numbers into binary. So we will go through both of these methods. I will start with first method. You take the binary base value. So base value of binary is 2. So now you are going to divide the decimal number by this base value. So let's take decimal 25. Now you have to divide by this base value 2. So let's get the answer. It is 1, 2. Now 2 into 12 is 24. So if you write 25 minus 24, you get 1 remainder. So that remainder I'm going to mention here. Then this process is going to continue until you get a number which is less than 2. So now you get 6. And now if I write 2 into 6 is 12. So then I can write 12 minus 12 is 0. So the remainder value is 0 here. Next one, again divide by 2, it is 3. So you can write 2 into 3 is 6. So let's say 6 minus 6 is 0. So the remainder is 0. Next one, 3 divided by 2. So it is 1. So if I multiply 2 by 1, so I get 2. So now let's say 3 minus 2, remainder is 1. So I'm going to put the remainder here. So now we have come to the final answer, which is less than this base value. So we are going to stop from here. And now I am going to write the binary number of this decimal 25. So I have to start from this cone actually. First I'm going to write 1. So this one. Then I'm going to write this one. Then I'm going to use this 0. Then I'm going to use this 0. Then I'm going to use this 1. So the decimal 25. So if I put the decimal base value which is 10, I can convert into binary. So computers will recognize it as 11001, which is in binary. But normally we say 1 byte consists of 8 bits. So we can convert this into 8-bit binary number. So when I convert this into 8-bit binary number, I'm going to count from this corner. 1, 2, 3, 4, 5, 6, 7, 8. So now I am going to put zeros to the front, so until it becomes 8 bits. So now 1, 2, 3, 4, 5, 6, 7, 8. So this is the binary equivalent of decimal 25. Now let's see the second method of converting decimal numbers into binary. In order to convert decimal into binary using second method, first of all you need to know the power values of this 2. So 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, and 2 to the power 5 is 32, 2 to the power 6 is 64, 2 to the power 7 is 128. So I'm going to stop from 128 because here I have 8 bits. So now the next thing what I have to do is I have to write these power values in a table. So first I'm going to start with 128, then I'm going to write 64, then 32, 16, 8, 4, 2, 1. So this table consists of 2 rows like this. So now let's take the same example. I'm going to use decimal 25 and I'm going to convert this into binary using this second method. So the very first thing what I have to check is whether this 25 is greater than or equal to 128. So let me start from here. 25 greater than or equal to 128. So actually this condition is false. If this condition false, I'm going to put 0 to this box. So let me put 0, right? Now since this is false, let's go to the next one. So in the next one, I have to see 25 greater than or equal to 64. Again, this condition becomes false. So again, I'm going to put a 0 here. So like that, I have to continue to the rest of the numbers. So now next one, 25 greater than or equal to 32. Still the condition is false. So I'm going to put 0 here, right? Let's go to this one. I'll write it here. 25 greater than or equal to 16. Now this condition becomes true because it's not equal but it is greater than 16. So if the condition true, you have to put 1 here, right? So now when I put 1 here, I cannot continue 25. The next thing what I have to do is I have to subtract 16 from this 25. So when I subtract 16 by 25, answer is 9. Now this 9 is the one which is going to continue. So the next one is I'm going to see whether 9 is greater than or equal to 8. So still the condition is true. Now I'm going to put 1 here because this condition is true. Now the next thing is 9 minus 8. So when I subtract 8 from 9, now 1 is going to continue through the table. So now the next one is I'm going to see 1 is greater than or equal to 4. So the condition is false. If the condition false, this becomes 0. Then here I have to see 1 is greater than or equal to 2. Again the condition is false. So that means 0. Next part is 1 is greater than or equal to 1. So now the condition becomes true. It is not greater than but it is equal to true. So the condition becomes true. It becomes 1. So if you write the 25 in decimal, if I write the same thing in binary, I am going to get an answer like this: 0, 0, 0, 1, 1, 0, 0, 1. So this is decimal 25 in binary. So these are the two methods which we can convert decimal numbers into binary.